Differential phase shift keying (DPSK). Introduction. There are two kinds of modulation techniques: analog modulation and digital modulation. In differential phase shift keying (DPSK), the period of the modulated signal is moved comparative with the pulse signal component. DPSK method need not bother with a reference oscillator. This is a DPSK waveform. 0 is the information bit low, and 1 is the information bit is high. Theory. DPSK modulation. DPSK is a strategy for BPSK where there is no reference phase signal. Modulation encode to separate signal, namely the carrier signal as well as the modulating signal. The stage shift of each sign is 180 degree. The serial input data can be applied to the SNO gate, and the output of the logic gate is feedback again to the input via 1 bit delay. As NOR gate output is applied to the balance modulator. So this is a DPSK modulation block diagram. Serial input data, gate SNOR, 1 bit delay, carrier and DPSK. Now we move to the DPSK demodulation. In this modulator, both the pass piece and the turn around bit are contrast and one another. DPSK signal is applied to reasonable modulator utilizing one cycle defer input. Signal is prepared to deliver toward lower frequencies utilizing a low pass signal. From that point forward is communicate to a sharper circuit for further developing the interesting double information. Sharper circuit is the Schmidt trigger or comparator circuit. This is a block DPSK demolition block diagram. Dpsk signal, 1 bit delay, move to the balance modulator, go through to LPS, then to the sharper and recovery bit data, recovered binary data. Then we move to the differential phase shift keying application. The uses of differential phase keying chiefly incorporate remote correspondence like RFID, LANs, and Bluetooth. This well-known application among them is Bluetooth. Any place choice of DPSK have been utilized like 8 DPSK and pi per 4 DQPSK adjustment. It is utilized to send information through the transporter wave by changing its phase. PSK eliminates the requirement for reliable reference signal to the finish of the recipient by adding to central task toward the finish of the transmitter. Then we move to the DPSK advantage and disadvantage. The advantage of DPSK incorporate the accompanying. This modulation need not bother with the transporter signal toward the finish of the receiver circuit. Accordingly, compound circuit are not needed. The memory of DPSK necessity is low access to BPSK modulation. Then the non-reliable beneficiaries are basic and cheap to develop. Along this line, widely utilized is remote correspondence. Then we move to the disadvantage of DPSK. The bit error rate or short app blunder is high and in DPSK differential to BPSK. The impedance of conversion in DPSK is more. This modulation utilized two sequential pieces planned for its reaction. Along this line blunder, in essential piece makes mistake inside the ensuing piece just as continual mistake spread. Okay, tweet this mean modulation. So block diagram and domain lab. Radial integer to DPSK, AWJN, DPSK, scope, constellation diagram, sine wave 1, real to imaginary, sine wave 2, product 1, product 2, adding as to scope. Then we move to the MATLAB Simulink. Okay, this is DPSK Simulink block diagram. Okay, the block diagram, random integer block diagram. Random integer generator, we set size, we set with 2, and the source initial seed Parameter initial seed 37, sample time is 1, sample per frame 1. Output data type example. Then we move to the next block diagram. Dpsk modulator baseband. Array number we set to input type integer, constellation on the ring, binary, and phase rotation. And then we're using pi. Then we have to add white Gaussian noise. Initial seed with 67 mode, signal to noise ratio. With 10 dB, number of bit per symbol we set to input signal power is 1 watts and symbol period is 1 second. Then the next block diagram is DPSK demulator baseband. Array number we set to 2, output type integer, constellation ordering binary, phase rotation pi. And this next part is sine wave block diagram. Okay, sine wave diagram using sine type is time based, time use simulation time, amplitude we set for 4, and frequency we using 8 pi, and phase radian is 0, and sample time is 0.001. We have complex to real imaginary. Then we have sine wave 2 is same with sine wave 1, amplitude is 4, frequency is 8 pi, and phase per radian pi per 2, and sample time is 0.01. This is product 1, nothing with number of input is 2. Product 2, number of input is 2. Adding is nothing, just same sign symbol. Okay, so then we run. Okay, as you can see, this is constellation diagram. At the right one, here we have 1, 2, 3, 4, 5, 7, 8 dotted. And the left one you have 3 dotted. As you can see, we're using 10 seconds for the default. Okay, then we move to the scope. So this is an input wave 100111101, and the modulator wave is 100111101. Move to the Dpsk form. Okay, so this is an input wave 100111101. After modulated, the Dpsk modulator waveform should be is W and the M waveform. Then we move to the next conclusion. We move to conclusion. This assignment presents the study of various scenarios aiming to suppress the undesired noise. The differential of DPSK scheme depends on the difference between chassis phases that can be significantly simpler to implement than ordinary PSK. The DPSK has become the format of choice for long-haul optical transmission system due to the 3 dB improvement in receiver sensitivity, and then able to understand the knowledge of DPSK, able to explain the basic principle of DPSK, and able to apply the concept in utilizing the electronic software, and lastly, able to produce and organize data collection table. Okay, that's all from us. Thank you.